Hello everyone. Today we are doing some application based questions. So first question is that a particle of mass m with charge q moving with uniform speed v normal to the uniform magnetic field b describes a circular path of radius r. Derive a expression for the time period of revolution and kinetic energy of the particle. So any charged particle, if we are throwing in a uniform magnetic field, then it acquires the circular path. Suppose here if I take this as a uniform magnetic field, okay, and if a charged particle q is thrown into this into this magnetic field b bar, so with certain velocity v, so it comes into the magnetic field and it what acquires the circular path. Okay, so for that they are asking to find out the time period for the revolution. So we know that if any charged particle, if we are throwing into the magnetic field, so force is acting on that particle, charged particle, and that is nothing but qvb sine of 90, sine theta. So here theta is 90, so sine 90 becomes 1. So we can write here qvb is equal to force, and this is my equation number 1. V is a velocity, q is a charge, and b is the magnetic field. As this uh, charged particle acquires the circular path, then that the force is responsible for circular motion, that is a centripetal force. So that force is nothing but mv square by r. So you can consider this as equation number 2. So now here both the equations are in the form of force. Then there is here LHS are same. That means their forces are same. Then you can equate this. So QVB divided QVB is equal to mv square by r. So this v and one v is get cancelled, and you can write the equation for v, that is velocity. So velocity is nothing but we can write it as the r, you can transpose here qb into r divided by m. So this is nothing but what a velocity we got. But here they are asking in terms of time period. Okay, so time period, here velocity we have. So once we get the velocity, we know that velocity is equal to distance by time. So this acquires circular path. That means the circular path length is nothing but a circumference, and that circumference is nothing but 2 pi r. So we can write here, we can write this velocity ka formula. Velocity v is equal to distance by time period t. So here distance is nothing but 2 pi r divided by t. This is nothing but what your velocity. So here again, if you consider this as equation 3 and this as equation number 4, so again these both are, we wrote it for the velocity. So again you can equate this. So once you equate this, then we will get here qbr upon m is equal to 2 pi r divided by t. So r and r is get cancelled, and we can say that here time period you can transpose to that side. So t is equal to 2 pi m upon qb. So this is the derivation or expression we got it for the time period t. Okay, now the second bit they are asking about the kinetic energy. So kinetic energy normal for formula kinetic energy is nothing but half mv square. So here half you can keep it as it is, the charge possessing mass m, keep it as it is. V we have v velocity, we got it as here we have a velocity value is nothing but qbr divided by m. This velocity value you can substitute over here. So we can write it as qbr upon m whole bracket square. So half m, simplify this, q square b square r square divided by m square, because its power is 2. So here this square and this mass is get cancelled, and we will get the final expression for kinetic energy is q square b square r square by m. So this is the final expression for kinetic energy. So these are the two things which they are asking here for time period and for kinetic energy that we did. Hope you understood this video. Thank you.